Okay, so just to make a little short note up here, I want you guys to understand the first thing or first step in solving equations is to simplify. And then second is we're going to isolate. Okay, so that's how we solve. That's how we solve equations. So we're going to look to see if we can simplify anything first, and then once everything is simplified, then we can start isolating our variables. So all solving equations does is finding out an unknown value in math, right? So an unknown value in math is nothing more than a letter. Okay, for instance, in number one, we have an unknown value right here in P. Okay, and so this is what I want you guys to understand. I'm going to kind of do these a little bit different, but this is my unknown value. So I don't know what P is equal to, right? But if I know anything about math, I know that if P is a number and I were to use the order of operations, I would first take P and I would subtract 5, right? I would do that. Then I would multiply by 3. Okay, and then I would add 8. And then I would end up with 17. Okay, and so that's kind of my blueprint and how to solve this if I wanted to, right? So I'm going to do one thing first. So first, algebraically, how would I solve this? So can I simplify anything? Yes. Okay, so I can solve this one of two ways. The first way, I can simplify if I wanted to by multiplying 3 to P and -5. So that's just called distributive property, right? So I would have 17 is equal to 3P minus 15 plus 8. So I could do it that way, right? And then I'm still simplifying because I can still combine these two like terms. So then I would have 17 is equal to 3P. What is this? Minus 7. Okay. And now in this step, there's no more simplifying. So in these first two steps, I did my simplify. Okay. And now I want to be able to isolate. Well, again, I want to isolate this number that I don't know. Okay. And that number is P. It's represented by the letter P. So how do I do that? Well, I first start to isolate that. So I add 7 to both sides. And then I'm left with 24 is equal to 3 times P. And then I divide by 3. And so I get 8 is equal to P. Okay, and so I figured out what the value of P was. All right, so that's one way to do it, by distributing first. Another way to do it, if I had 17 is equal to 3 times P, the quantity of P minus 5 plus 8. Since I only have one variable here, I can just kind of isolate from the beginning. But again, that only works with one variable. So that's why I always say simplify first. But if I wanted to, right, I could subtract 8 to both sides. So this is just a different way of working it. And that gives me 9 is equal to 3 times the quantity of P minus 5. Then I could divide by 3. That gives me 3 is equal to P minus 5, because those two would cancel. And then at the end, I could add 5 to both sides. And that gives me, again, 8. Okay, and what I did here, again, this only works with one variable, is basically I use these steps to undo that. So again, if I understand that I start with the number P, I'm going to subtract 5, multiply 3, add 8, and I end up with an answer of 17. Well, I can reverse my method here in order to solve this. And I could say I'm going to start with 17. Then I'm going to subtract 8, right? Because these are inverse of each other. I'm going to divide by 3, again, inverse. And then I'm going to add 5, right? Then I should know what P equals. So let's do that. If I take 17 and I subtract 8, then that gives me 9. Then I take that 9 and I divide it by 3. That gives me 3. I take that 3 and I add 5 to it. That leaves me with the number 8. Okay, so 3 different ways to solve the same problem. Just make sure you can do one of these 3 methods. Okay, so you use the one that's easiest for you, right? Okay, so again, number 2, there are multiple ways to solve this one. So again, I want to isolate. I want to isolate my variable. That's my unknown. So I have 4 times m minus 3 divided by 7, and I equal 8. So how do I solve this one? One way to do that is by multiplying both sides by 7. So that cancels this 7. So I don't like working with fractions. So I get 4m minus 3 is equal to 21. Then there's nothing left to simplify, so I start isolating my variable. 4m is equal to 24. And then I can divide by 4. M is equal to 6 this time. So that's one way to do it. Again, another way to do it. Right, we remember having fractions, so I can easily change 3 to a fraction by putting it over 1. If I have one fraction equal to another fraction, then that means I can cross multiply. So 4m minus 3 times 1, right? I'm going to write it out so you guys see what I'm doing. So this times 1 is equal to 3 times 7. So 4m minus 3 times 1 is just 4m minus 3. 3 times 7 is 21. Nothing left to simplify. So now, again, I isolate my variable. Divide by 4. M again is equal to 6. If I want to use the words again, then we always start with our unknown, so m. Then we know that we're going to multiply 4 first to the m. We're going to subtract 3. We're going to divide by 7. And we end up with an answer of 3. So if I want to undo this, right? So I went down like this. If I want to undo it, then now I'm going to start with 3. I'm going to multiply by 7. I'm going to add 3, and I'm going to divide by 4. And then I'm going to know what m was, right? So we start with 3, multiply 7, that gives me 21. Add 3 to that, that gives me 24. Divide by 4, that leaves me with 6. Okay. All right, number 3. Okay, so now I have the same variable, but I have it more than once. Okay, so this is where we do have to simplify. So I want to combine those variables so that I end up having just one. So here we need to move it across the equal sign. So in order to do that, I have to do one of 2 things. I am going to subtract 8b to both sides. So that cancels the 8b on this side, and that leaves me with negative 6b minus 5 is equal to 1. Okay, so I've combined my variables. Okay, so I simplified. And now from here, okay, I can do it again one of two ways. If I know that I start with B, so we'll do it the way that I feel like you guys understand more. So if I start with B, the first operation occurring to that number is multiplying by -6, and then I subtract 5, and I end up with 1. Okay, so how do I undo that? I'm going to start with 1. I'm going to add 5 and divide by -6, and that's going to tell me what B was. So 1 plus 5 is 6. 6 divided by -6 gives me a -1. So we're going to see if B is equal to -1. So algebraically, what does that look like? We add 5 to both sides to isolate or to start isolating my variable. Then we divide by -6, and B is equal to -1. So you get the same thing, right? Okay, but we can't do that until we have combined our variables. Okay, so again, we have variables on opposite sides of the equation. So let's subtract 1.8x to both sides. Okay, so what am I left with when that happens? These cancel. I'm left with 2.8 on the left side. On the right side, I think this gives us 0.7x plus 2.1. And so now this is ready to go, right? This is the key. So again, if I start with x, I know that x is going to be multiplied by 0.7, and then we're going to add 2.1, and I get an answer. I end with 2.8. Let's undo that. So we're going to start with 2.8. We're going to subtract 2.1. We're going to divide by 0.7, and we're going to know what x is. So 2.8 minus 2.1 gives me 0.7. 0.7 divided by 0.7 should give me 1. So let's see if we're right. Algebraically, subtract -2.1. 0.7 is equal to 0.7 times x. Divide by 0.7. And in fact, x does equal 1. All right. So number 5, we do need to simplify. So first thing we do to simplify is distribute. Okay, so we get 2x plus 8 is equal to 3x minus 6. Again, I want to combine those variables. So let's move the -2x to the right side of the equation. We do that by subtracting 2x. Okay, those cancel on the left. I'm left with 8 is equal to x minus 6. Now, again, this is the important part. Okay, algebraically, this should be an easy part to solve. I just need to add 6 to both sides, and I get, I believe that's 14 is equal to x, or x is equal to 14. Okay. And then for part 6, or number 6, I mean, okay, again, I need to distribute. The right side is easy, but this left side, this negative, it's like saying -1. Anytime you have a negative in front of parentheses, we're essentially distributing a -1. So this gives me 5 minus n plus 4, because -1 times negative 4 gives me a positive 4. And then the right side is 3n plus 6. Okay. Again, I need to combine, right? So I have negative n plus 9 is equal to 3n plus 6. I have variables on either side, so let's combine those variables. So I do that by adding n to both sides. I'm left with 9 is equal to 4n plus 6. And then this is where I would start if I wanted to use the words, right? I start with n, then I would multiply by 4, then I would add 6, and I would end with 9. So how do I do that? If I undo that, I start with 9, I subtract 6, I divide by 4, and that's going to give me my n value, right? So what does that give me? 9 minus 6 is 3. 3 divided by 4 is 3/4. So let's see. Minus 6 to both sides. 3 is equal to 4n divided by 4. So yes, n is equal to 3/4. It's okay to get a fraction sometimes. All right, number 7 and 8. So these are kind of special cases, right? So one of these is going to be an infinite number of solutions, and the other one's going to be no solutions. Okay, so we need to figure out what happens when this happens. How do I know that it's going to be one of those two? Okay, well, let's start working this out. I have to simplify. So 2 times 4 is 8, and then 2 times x is 2x, minus 5 is equal to 2x plus 3. I need to simplify some more, combine 8 and negative 5, so 2x plus 3 is equal to 2x plus 3. That's the exact same thing, right? Some of us might notice that, some of us might not. So let's say we subtracted 2x to both sides, and look what happens. The x cancels on the left, the x cancels on the right. I'm left with 3 is equal to 3. So if your variables cancel completely and they go away, you're going to be left with a statement. Here it says 3 is equal to 3. That's a true statement. If that statement is true, then we are going to have many solutions. Okay, so basically it means that all real numbers are a solution. Okay, so any number I pick to plug into this equation would be true. For instance, let me type into Desmos here just to kind of prove my point. Okay, so just using this as a calculator, if I had 2 times 4 plus, so we normally had x right there, minus 5, and that was equal to 2x plus 3, right? Well, these two are equal to each other. Okay, so basically it's saying that this left side of the equation is going to be equal to this right side, right? Well, if I plug in an x, let's say x was 5. So if I plug in a 5 there and a 5 there, whoops, this is 2 times 5, then those two numbers should be the same. And then I can do that with any number because it was a true statement, right? Let's say it was 11, x was 11. So I change that to, 11, and they're the same two numbers. So again, I can do that with any number, 131. It's going to be the same number, okay? So that's why basically we can say it has many solutions. We can say the solutions are all real numbers, or we can say it's an infinite number of solutions. So number 7 is many solutions. So we've used that one. So you can already assume that this is going to be no solutions. So let's show you what number 8 looks like. Well, again, we distribute. 6 times x is 6x. 6 times 7 should give me 42, if my math is correct. And then we still have the minus 20, and it's equal to 6x. I can continue to simplify. 6x plus 42 minus 20 gives me 22 is equal to 6x. And then now I can start isolating. If I subtract 6x to both sides, again, that same thing happens. My x's cancel. And what I'm left with is 22 is equal to, well, when everything cancels on one side, that's just 0. Okay, so this is a false statement. 22 does not equal 0, so that's false. So that means number 8 has no solution. So that means that there is not a value for x, there's not a number for x that would make this equation a true statement. All right, that is it.